Good evening, my YouTube viewers. It is Crystal here, and I'm just here because I wanted to give you a code review on semi-supervised learning. And I actually got the code from from a YouTube video, and the title of the YouTube video is a tutorial on semi-supervised learning, and it was from Septars Goswami. But the thing is I don't feel guilty about doing the code review, and the reason why is because I added a lot to it, and the code that he gave actually didn't work when I tried to run it up, and it took me a long time to get it to work, and I had to make changes to the code to get it to work. So I don't feel guilty about doing this code review since I had to make so many changes to it. But I did tell you the video that I got the code off of, but it's the code on the video is not the same as what I'm giving you because I had to make changes to it. So this is on semi-supervised learning, and what semi-supervised learning is you have a label, and some of the rows are labeled, but most of them are not. And so you take the small amount of labeled rows and you build a model on those labeled rows, and then you go ahead and predict upon the unlabeled rows. So that's why they call it semi-supervised, because you have a small amount of labeled data and then you have to predict upon the data. So I created this program in Google Colab, which is Google's free online Jupyter notebook. And then what I did was, after I created the program in Google Colab, I had to import my libraries. And so when I imported the libraries, I imported pandas as PD, that's your data frame library. I imported NumPy as NP, that's your numerical computation library. I imported matplotlib.pyplot as PLT, that's a graphics library. I imported CForm, which is a graphics library built on top of Matplotlib, and I imported the warnings so it would ignore the warnings. And the reason why is because when we go through and do the machine learning, we've got some warnings in the machine learning, and I didn't want to see those warnings, so I just ignored them. So after we load our libraries, what we're going to do is we're going to load the data set. And so this is wine, really. So it's always a good idea for me to do a code review because I had written iris down, and it's not iris, it's wine. So from sklearn.datasets import load wine, data equals load wine, brackets as frame equals true, x equals data, y equals data target. We check the shape. X.shape is 178 by 13 columns. Y.shape is 178. And then what we're going to do is we're going to create a data frame from this. So df equals x, df target equals y, and then what we're going to do is we're going to shuffle the data set. So df equals df.sample, brackets, frac equals 1, random state equals 42, and then you can see that we have shuffled our data set. Now what we're going to do is we're going to analyze the target and the data set, and you can see that there are 3 classes, 0, 1, and 2. And now we're going to define our dependent and our independent variables. Y equals df.ilog, square brackets, colon, comma, -1. That means that y is the last column in the data frame. x equals df.ihoc, square brackets, colon, comma, colon, -1, square brackets. That means x is all of the columns in the data frame except for the last one. And then we check our shape of our x and y. So you see 170 x shape is 178 rows by 13 and y shape is 178 rows. So let's see what we had in the last one. So in the last one we had 178 by 14. And then so we just dropped the last row off to make x. So what we're going to do now is I just wanted to show a picture of what the data set looks like in memory. And so you can see the one data set in memory here. And it says font size is small. That's a 2D diagram. So now what I've done is I've made a 3D diagram. So you can see what the data looks like in the computer's memory in 3D. So that's really neat when you look to see where the data is fitting in memory. So now what we're going to do is we're going to normalize x and we're going to convert all of the values, all of the cells to a value between 0 and 1. And the reason why that is because it is easier for the model to make predictions if the cell values are close together. So that's why we convert all of the cell values to a value between 0 and 1. So now we're going to split the data frame and we're going to use train test split sklearns to split the data frame. So x train, x test, y train, y test equals train test split, x, y, test size equals 0.3, random state equals 42. So we check the shape of x train, y train, x test, y test. And so you can see x train is 124 by 13, y train is 124, x test is 54 by 13, y test is 54. And now what we're going to do is we're going to define our unlabeled data. So x train x unl, y train y unl equals train test split, brackets x train comma y train, test size equals 0.7, random state equals 42. So that means that the test size is going to be 70% of train. So we check our x train, x unl, y train, y unl. So x train is 37 rows by 13 columns. X unl is 87 rows by 13 columns. Y train is 37 rows and y unl is 87 rows. And so what that means is you're only going to have a small amount of labeled data in the data set. And so it has to make predictions on this small amount of labeled data, and it has to make predictions on the rest of them. So what we're going to do is we're going to select our model, and in this instance we're using sklearns SVC. So CLF equals SVC, brackets kernel equals linear, probability equals true, C equals 1, max iter equals 1000, fit x train y train, and so you have a 96% accuracy on that, on the x test y test. And now we're going to predict on the unlabeled data. So CLP equals CLF.predict proba x unl, lab equals CLF.predict x unl, and then print CLF.score x unl, y unl, and so that's a 94% accuracy. And now what I wanted to do is I wanted to check the accuracy between y unl and the labels, and the accuracy is 94%. So now what we're going to do is we're going to create another data frame. So df equals pd.dataframe CLP, columns equals 1 prob, 2 prob, 3 prob. df lab equals lab. df max equals df 1 prob, 2 prob, 3 prob, max axis equals 1. And so what the max does is that takes the highest value of the 3 values in the data frame. And then it takes the labels as well. So now what we're going to do is we're going to plot the confidence. So plt.hist brackets df square brackets max square brackets brackets. So this is a histogram of the plot, and you can see most of the plottings are around the 0.9 range. Now what we're going to do is we're going to choose the right confidence level. NC equals np.arrange.35,1,0.03. ACC equals np.mt22. I equals 1. For K in np.nd iter NC. Confidence interval equals df max is greater than K. Confidence interval equals conf ind.as type int. Xtrain 1 equals np.append xtrain, x unlil.iloc square brackets conf ind colon square brackets axis equals 0 brackets. Ytrain 1 equals np.append brackets ytrain, df.loc conf end, lab square brackets brackets. CLF equals SVC kernel equals linear probability equals true, and CF equals 1, and I'm going to say max iter equals 1,000. Because that's what we had in the last one. Max iter equals 1,000. So we're just going to put max iter equals 1,000. Dot fit xtrain 1 ytrain 1. Accuracy I equals CLF dot score x test y test. I equals I plus 1. So now we're going to plot the confidence versus the accuracy. And x equals pd dot series brackets ACC, index equals NC. X dot plot brackets PLT dot title brackets confidence versus accuracy. PLT dot X label is confidence. PLT dot Y label is accuracy. PLT dot show. And this is what it looks like. So basically the graph that was plotted out on the program I did is different from the black graph that was plotted out in the YouTube video, but I had to make changes. I had to make changes to this bit right here just to get it to work. If I didn't make changes, it wouldn't work. And I can't say why it worked on the YouTube video and it didn't work on mine. Maybe it's because the YouTube video is older and they're always making changes to Python and Pandas and NumPy, and maybe that these changes they made to Python, Pandas, and NumPy affect the functionality of the program. But that's how it works. So I'm going to go ahead and complete this code review. I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you very much for watching my code review. I look forward to making more code reviews for you in the future.